So let's start with the chapter of wave. Now, there are many examples that is given to you to explain what is wave. For example, there is a pond, and in that pond you drop a stone. Now, what happens is that there is a disturbance that is being created. So, this is one of the examples that you will find while describing wave. Now, what is the relation of a stone dropping in a pond and the disturbance? Now, if you look closely, there is a force that has been generated, or there is a disturbance that has been created in the surface of the water. In the surface of the water, and this is the force, and therefore a information has been passed. Say suppose if there is a big wave, then you know that a heavy object has fallen. If there is a small wave that is created in your pond, then you know that a smaller force or a smaller object has been fallen. So now you can see that because of the amplitude of the displacement, or you can say because of the time period. Now these are some of the terms that I'm using: time period or amplitude. These are some of the things I'm using. Before this, let me explain to you what is amplitude and time period. Say suppose you drop and there is a slight disturbance. First it will go up, and then it will go down, and then again it will come back, and then again it will go up, it will go down, and it will come back. So this is the process. So amplitude is the maximum direction. Amplitude is the maximum direction that a body can have. That is, from its mean position, the maximum amount of displacement. From its mean, the maximum del x. This is the displacement. This is the maximum disturbance that it can have. This is known as del x. So this is what amplitude means. Now I've also used the term time period. Time period is something when a wave moves, it's starting from here, and again when it reaches the same point, the time required to start from here and to come back to its original position, it is known as the time period. Now please keep in mind this and this. Sometimes students also get confused regarding this 2 point. Actually, this is not the time period. The reason why this wave or this part is going up. See, suppose in waves, you see it goes in a wavy manner. So this part goes up, then again if you observe, this part goes up, again after some time this part comes down. So this part comes down. It goes up, again goes down, and again it comes down, again it goes up. So the surface of the water is something like this. First it's something like this, then it becomes something like this, then straight, then this, then this, then this. Then again, if I draw back this, then this, then again it's less, again it's center, then this. So this is what happens in a particular wave. At this is my wave that I am looking into. So this wave behaves like this. First, while striking, it goes up, then slowly and slowly it will go down, then slowly and slowly it will go under the surface, then again slowly and slowly it will decrease, then slowly and slowly it will increase. So this is going up and down. So now you see, just by taking this two, or just by taking this point and this point, this is not my time period, because over here this wave is going down. Over here this wave is going down. That is, it's increasing, then it's decreasing, then it should decrease, then again it should increase. So only then you will have the complete time period. Look over here. This is going down and this is going up. So this is not the time period. You should have a position where both of them are going up. That is, it is completing a complete rotation. Like the time period to again go up. Say suppose this is the flat surface, then again it should go up. So the time period is this amount. That is the time taken. See, after getting this flat surface, it will start to rise. So the time period when we will get a flat surface and after that it will start to rise, that is the total time period. Now over here, it will start to go down. So this is not the actual time period. It has not completed one complete cycle. So we need to see the cycle. So the time period is what? That is the total time required from this point to come to this point. That is the total time. So this is the time period. So now we have defined time period and now we have defined amplitude. So we are in a position to say or give a basic definition of wave. Wave is nothing but a transfer, a medium or a transfer of energy. Transfer of energy which creates a disturbance when in the medium. And this is how waves are propagated. This is how information and energy is propagated. Now, there are a lot of definitions, and among them, this is one. Among this definition, this is one. Now, what you have to keep in mind is that sometimes there may not be a disturbance of the medium because electromagnetic waves does not create any disturbance in the medium till now, till what we have known, because science is a huge field. There are many things we till now don't know about. But when electromagnetic waves travel in vacuum, we know that there are no such substances that is present over here. So what we can observe is that waves transfers energy that we are sure of. Wave transfers energy that we are sure of, but it may or may not create disturbance in a medium. So these are some of the things that may or may not be. So a universal definition of wave, according to me, might be there is a transfer of energy and information without the actual transfer of material that it's traveling to. That is known as wave. This is known as wave. This is your final definition of what is actually wave. In this way you can understand what is wave.